Well, good morning there, ladies and gentlemen. Let's use this wonderful Dixon Ticonderoga number 2, hashtag not sponsored, to make a graph of this polynomial function, shall we? So we've just been practicing these, so if, yeah, let's just go. Let's dive into it, shall we? So look, first thing you got to do is you got to find the degree. And the degree of this, since it's in unfactored form, the degree is 3. It's the largest exponent. Leading coefficient is positive, right? And from that, we can tell the end behavior. The end behavior, because the degree is odd, it's either going to go, because the degree is odd, it's either going to be this way on the ends or this way on the ends. Because it's positive, it's going to look like this. So the end behavior is going to look something like, we don't know what's going to happen in the middle, but it's down, left, upright is how we describe it, right? So after we get done with that, we're going to find the y-intercepts. To do that, you put 0 for x, plug in 0, and plug 0 here, plug 0 there, plug 0 there. You're left with 0, negative 28. This is a little easier than if it was in factored form. There's less work to do because it's 0 plus 0 minus 0 minus 28 equals negative 28. All right, now x-intercepts, what you got to do is you take the entire equation, you set it equal to 0, and then you solve it. Okay, now this one is, we're going to try to factor it. There are 4 terms. Terms are separated by plus and minus. We have 1, 2, 3, 4. The thing with 4 terms is what you want to do is you want to see if you can factor by grouping. You can't always, but sometimes you can. So we're going to find out. Now factor by grouping, what you're going to do is you're going to make 2 groups separated by a plus sign. So we're going to have this group here. Check this out. There we go. This and this are exactly the same. Do you see, if I got rid of these parentheses, it would just look like a plus in the front. Plus a negative is just negative. So the reason we do that is it keeps us from making like a procedural error when we factor these. Now, we factor each group, see if we can get those groups the same. Here they've got a common factor of x squared. X plus 7 is what's left. Over here we can take out a negative 4 and we have x plus 7. Again, see, negative 4x, negative 28. Now, putting it all together, x squared minus 4 and x plus 7. See, look, if you were to distribute this binomial to this binomial, if you were to write it out, you would get x squared times this, which we have here, and then minus 4 times this, which we have here. Do you see? And then if you were to distribute, you'd get x cubed plus 7x squared. Here you get minus 4x and minus 28. So factoring is the opposite of distributing. Now we take each factor, set it equal to 0. This is a difference of squares, so we could factor it more if we wanted. We could just use inverse operations if we wanted. So you can see we get x equals 2, x equals negative 2, and from this one, we get x equals negative 7. So we have 1, 2, 3 x-intercepts. We have negative 2, 0, we have negative 7, 0, and we have 2, 0. All right, so let's put all these things on the graph right here. Here's all the information we have. 3 x-intercepts, 1 y-intercept. We know the end behavior, so let's sketch a graph. All right, that looks like negative 28 to me right there. That's a y-intercept. X-intercept of negative 7. Got another of negative 2, positive 2. And we know that it's going to go down to the left, and we know that it's going to go up to the right. And we have a maximum of 2 turning points. So in this one, we don't even have to do any test areas. Like, we don't need to plug in a number between negative 7 and negative 2 to see if it's positive or negative. I know it's going to be positive because we're only allowed 2 turning points. And so that's going to have to go up, down, and then back up again. Now, it's going to be smoother than that, but it's going to look like that has to. Now, let's say we weren't sure of that right away. We already know between negative 2 and positive 2 that the output is negative because it's down here. And we found all the x-intercepts. The degree is 3, and we have a maximum of 3 intercepts. And so we got them all. There's not going to be any more. Let's see. If we wanted to check and see what the output was between here and here, we would find out it's positive. So if we wanted, we could put in like a negative 5. And so that would be negative 5 cubed plus 7 times negative 5 squared. Oh man, I'm going to run out of room. I'm going to run out of room. Here, let me do it down here. F of negative 5. So all we're going to do is we're going to just verify that this really goes up right here. This doesn't help us answer this question, but it is something you have to do often. Sometimes you don't know what happens in between 2 x-intercepts. You don't know if it goes above, if the output's positive or negative. Because what can happen is it can turn around and go back up. and touching in there. It can't in this case because of the limitations of the number of x-intercepts. So what I'm saying is, I'm showing you a method that you can use if you're not sure what happens. So pick a number between these two, -5 for example, plug it in, see if the output's positive or negative. If the output's positive, that means y is positive, that's above the x-axis. If the output's negative, then it's below the x-axis. So here we go. Now -5 cubed plus 7 times -5 squared minus 4 times -5 minus 28. Okay, so this is -125. Let's see. This is 25, 7 quarters. So that's plus 175, I think, right? Seven quarters. 8 quarters is $2. So this is 7 quarters. Okay, plus 20 minus 28. So let's see. We don't need to know the exact number. This is -8, and that's -133. Then plus 175. That is greater than 0. That's positive. So there's our graph right there. Now, one thing I would encourage you to do, if you're doing these on your own, you're not really sure, you're not feeling very confident, is use your good old buddy Desmos, D-E-S-M-O-S. There's a website, desmos.com, or you can use the app right here. It's free, it's wonderful, desmos.com. You can just plug in all the stuff, see what it looks like. So anyway, that's it right there. Hope it's been helpful. If you guys have questions, let me know, and I'll talk to you later. Have a good day.